Hello, students! Have you ever thought about something really amazing? You're reading your book, and then you suddenly look up at a bird flying outside your window, and your eyes just focus instantly. It feels like magic, right? Well, today, we are going to understand the science behind this incredible power of our eyes. So, here's our plan for today. We'll begin with a blurry situation that we all know. Then, we will exploit the eye's special autofocus power and see how it actually works. We will also look at the limits of our vision, what happens when this focusing fails, and, very importantly for you, how to use this knowledge to solve numericals in your exams. So, let's begin. All right, first up, a blurry situation. We are going to start with something that I am sure every single one of you has experienced at some point in your life. So, here's a question for you. Why does a book become blurry when you hold it too close to your eyes? You can even try it right now. Just take your hand and bring it closer and closer and closer to your face. See? It starts to get blurry. Why does that happen? Well, the answer to this simple question is the key to our whole topic today. So, the reason we can see clearly at most distances, but not when something is too close, is because our eye has this remarkable built-in autofocus system. And in science, we have a special name for this ability. This incredible ability is called the power of accommodation. So what is it? It is simply the ability of our eye lens to adjust its own focal length. You can think of it like this. The lens can change its focusing power, and it does this with the help of some tiny, very important muscles. It's almost exactly like the autofocus feature in a modern camera. Okay, so we know what it is, but how does it happen? How does our eye actually manage to change its focus? Let's look at the mechanism behind this accommodation. Now look at this diagram. There are two main parts we need to know for focusing. First, we have the crystalline lens. This is our eye's natural lens. And second, we have the ciliary muscles. You can see them here surrounding the lens. These two, the lens and the muscles, they work together as a perfect team. Now this table makes everything very, very clear. Let's look at it carefully. When we are viewing distant objects, let's say a tree far away, the ciliary muscles are relaxed. And when they are relaxed, the eye lens becomes thin. A thin lens has a long focal length. Now what happens when we view nearby objects, like the book in your hand? The ciliary muscles contract, they squeeze the lens. This makes the eye lens become thick, and a thick lens has a short focal length. So the main point to remember is, for nearby objects, muscles contract, the lens becomes thick, and the focal length decreases. This change is what lets us focus. But, just like any good camera, our eyes also have their limits. There's a certain point that is just too close for our eyes to focus. And then there's a point which is the farthest we can see. So let's now talk about these limits of our clear vision. Okay, let's start with the closest point. For a normal healthy eye, this distance is about 25 centimeters. This is a very important number to remember. And this minimum distance for clear vision has a special name. It is called the near point. So, if we have to define it, the near point is the minimum distance at which an object can be seen most distinctly and without any strain on your eyes. And you know what? This is the answer to our very first question. The reason the book gets blurry is because you are bringing it closer than your near point, closer than 25 centimeters. Your ciliary muscles are trying their best, but they just can't make the lens thick enough to focus at such a short distance. All right, so that was the near point. What about the far point? How far can a normal eye see clearly? Well, the answer is infinity. Yes, infinity. That is why we can see the moon and the stars, objects that are millions and millions of kilometers away. So the far point is the farthest point up to which the eye can see objects clearly. For a normal, healthy eye, this point is at infinity. Just think about that for a moment. Our range of vision is from just 25 centimeters in front of our face all the way out to infinity. It's truly amazing, isn't it? Now, this power of accommodation is wonderful, but sometimes it can weaken, especially as people get older. So what happens then? Well, this is where defects of vision come into the picture. So what are these defects of vision? It's actually quite simple. It's just a shift in the near point or the far point. For example, the near point might move farther away than 25 centimeters, or the far point might move closer, so it's no longer at infinity. When these points shift from their normal positions, our vision becomes blurry. Let's take an example to understand this better. Look at the image on the left. This shows a normal eye. You can see the light from a distant object is focusing perfectly on the retina at the back. Now, look at the image on the right. This shows a myopic eye. What's happening here? For this person, the far point is not at infinity anymore. It has shifted closer. Because of this, the light from a distant object is now focusing in front of the retina. And when the image does not form on the retina, the person sees a blurry image.
Okay, now for a very important part, especially for your exams. Why is it so crucial to understand all of this? Because beta, the questions you get will not just be about definitions.
In your board exams, they will test your understanding of these concepts. You will often see numerical problems, questions about vision defects, and to solve those problems correctly, you absolutely must understand the meaning of near point and far point.
So please, this is the most important tip for this topic. You must understand that the near point for a normal eye is 25 centimeters, and the far point is infinity. Knowing these two values is the first step and the most important step to solving the lens formula problems for vision defects. Please remember this.
And with that, I will leave you with a question to think about. Using everything we have learned today about accommodation, about the near point, can you explain why many older people need reading glasses? What do you think happens to their ciliary muscles? What happens to their near point as they grow older? Think about it. Thank you for joining me today.